Laksmi.
And I am Sucintia.
Today we would like to explain about motion of a mass on the spring. Okay, now we move to the Hooke's law. Okay, here we have a collide spring in its relaxed position. When we pull it down, so the spring will be stretched, and when we pull it a little bit, the spring will stretch a little bit too, and when we pull it with a greater force, the spring will stretch a much greater too. Okay, here is the example, and from this explanation we will have another question, which is what is the quantitative relationship between the amount of pulling force and the amount of stretch. Okay, object of known mass could be attached to the spring. For each object which is added, the amount of stretch will be measured, and then the force which is applied in each spring will be the weight of the object. This will be the weight of the object that attached in the spring. Okay, today this quantitative relationship between the force and then the stretch is we can find it in our textbook in an equation which is F spring equals minus K times X, which is the F spring is the force exerted upon the spring, and then the X is the amount that the spring stretches relative to its relaxed position, and then the K is the proportionality constant, often referred to the spring constant. Okay, when a stiff spring will have a high spring constant. This is the K spring constant where we have the stiff spring, so the spring will have the high spring constant, and then the units of the spring constant is newtons per meter. And then the negative sign, this is the negative sign above this equation. This is tell us about the direction, which is the spring stretches is opposite the direction of the force which the spring exerts.
Okay, now I want to present about force analysis of a mass on a spring. The restoring force causes the vibrating object to slow down as it moves away from the equilibrium position, and to speed up as it approaches the equilibrium position. So, what is the restoring force of a mass on the spring? Here, the diagram shows an air and the glider. The glider is attached by a spring to a vertical support. There are three dominant force X upon the glider. The first is the force of gravity. It is a rather predictable force, but in terms of its magnitudes and direction. After that, the force of gravity always acts downward. And then the second is the force of support. It's balance the force of gravity, and then it's applied by the air from the air track, causing the glider to lift it about the track's surface. And the third is the force of spring. Here, the force of spring can be found using the Hooke's laws. After that, the direction is always opposite with the direction of stretch and slow down. Suppose that the glider is pulled to the right of the equilibrium position and research.
Okay, the next is sinusoidal nature of the motion of a mass on a spring. Okay, here is the diagram. The level position in the diagram here are the same position used in the discussion before. We might remember again the discussion. So here A, where is A? A and E were positions at which the mass had zero velocity, where the C was the maximum speed, and and if the same motion detector that collected position time data were used to collect velocity time data, then the plotted data here, the A, B, C, D, and E will look like the graph below here. This is the graph. So velocity time plot. Here the velocity time plot for the mass on a spring is also a sinusoidal speed plot. Here is also the sinusoidal speed plot. Okay. The only difference between the position time, velocity, the position and time here, the position and time, and the velocity and time plot, the velocity and time plots, is that one is shift 1/4 of a vibrational cycle away from the other. Okay, in the plots that the absolute value of the velocity is greatest at position C. Here is the greatest. And the velocity of any moving object, whether vibrating or not, is the speed with a direction. The magnitude of this velocity is the speed, and the direction is expressed as a positive or a negative sign. Okay, in another cases, the velocity has a positive direction, and then its velocity is plotted above the time axis, here, and then the speed is greatest when the displacement of the mass relative to its equilibrium position is the least. Speed is least when the displacement the speed is least when the displacement of the mass relative to its equilibrium position is the greatest.
Energy analysis of a mass on a spring. Here, the mass on the spring moves from A, B to C. The kinetic energy is increased and the potential energy is decreased. Amount of this to form of the mechanical energy remains constant. So that the mass moves from C, D to E as the spring becomes compressed and the mass slow down. After that, the kinetic energy is transformed into elastic potential energy. Here shows energy bar charts for a mass on spring. Stage of cycle A, B to C, increasing change in speed and increasing in change in kinetic energy. After that, stage of cycle CD to E, increasing the change, decreasing change in speed and decreasing change in kinetic energy, and stage of cycle A, D to C, increasing change in speed and increasing change in kinetic energy, and stage of cycle C, B to A, in decreasing change in speed and decreasing change in kinetic energy.
Okay, the last topic is period of a mass on a spring. Okay, not all springs are created the same, and then not all spring systems are created equal. So here we can find the quantity with period. So here is the equation of period, which is T equals 2 times P times M per K, and which is the T is the period, and M is the mass of the object attached to the spring, and then the K is the spring constant of the spring. Okay, the equation can be interpreted to mean that more massive objects will vibrate with a longer period, and then their great inertia means that it takes more time to complete a cycle. So the springs with a greater spring constant have a smaller period, and then masses attached to these springs take less time to complete a cycle. And the greater spring constant means that they exert stronger restoring forces upon the attached mass, and this greater force reduces the length of time to complete one cycle of vibration. Okay, that is all from us. Thank you.